Welcome to testing endpoints with ASP.NET Core integration tests. I'm going to show you how to write ASP.NET Core integration tests for your backend in .NET. If you like this content, please like and subscribe for more similar content. And if you could share on social media, that would really help me a lot. This is an approach to testing that focuses on HTTP endpoints, the entire HTTP pipeline from start to finish. There's less focus on mocking, but it allows you to mock things like the database and external systems when you need to. We're going to be using ASP.NET Core minimal APIs in this example, but you can use the old school MVC style if you prefer. Both are valid for integration testing. Minimal APIs were introduced in .NET 6 for lightweight HTTP APIs. They're ideal for microservices and small applications. They have minimal boilerplate, and you can see some more documentation on this on the C# or .NET website. So why integration tests? Well, they test the application as a whole. They validate things like routing, middleware, DI, filters, all of the plumbing that goes into your app that you can't test with a unit test. You can catch issues missed by unit tests. There's a whole section on the Microsoft website for integration testing on ASP.NET Core, and you will be testing real HTTP requests and responses. Okay, that's really important because when you are testing an endpoint, when you're using an endpoint, you're not just calling a public API. You're sending a request and response. And what goes into the JSON in the request and comes back in the response is actually very important. If you skip that part, you're skipping a large part of testing your application. But when you do testing with ASP.NET Core integration tests, you're testing everything together. So it ensures the correct routing and middleware behavior. It reduces the reliance on abstraction and mocks. You can have less mocking and less abstraction in your normal code. So if you want to, you do not have to have abstractions for everything along your HTTP pipeline. You can test these things directly. If you do need to mock something like the database, there's no problem with that. But you won't be spending as much time writing mocks. And this is a critical thing for ASP.NET Core integration tests because it speeds up the process of actually testing your entire HTTP pipeline. Also, you will get better test coverage. If you cover a few of the happy paths, you will get most of the code that you're using throughout your endpoint, and you'll have a guarantee that the happy paths are working. And you can also test the exception paths and things like this as well. You're free to take your own approach to testing with ASP.NET Core integration testing. But some of the tips and some of the things that I have found are useful are to avoid mocking internal logic. There's no point in having a whole bunch of different layers and services and then testing those in isolation. You can test all of those together. You don't necessarily get as much test isolation, which, is up to you. If you want to layer your code with tests and add more unit tests, you can do that and still have a layer of ASP.NET Core integration tests. But it's not necessary for the purpose of testing your endpoint. You only need to mock external dependencies. And even then, you could use the real ones if you want to. Something I like to do is have a flag on my tests that allows for mocks, mocking the database, or testing the actual database. In those cases, what you can actually do is you can run a more comprehensive test suite, say once a night, when you're not depending on that for a pull request to come through. And that way you can include the entire database or even the external systems. So what you're getting is something that's very similar to a Postman test or a curl test, but the difference being that you can swap that out for mocks when you're running locally and run really quick tests. By the way, ASP.NET Core integration tests are very fast. You do need to spin up the entire ASP.NET Core framework to run them. So they're a little slower than unit testing, but they give you so much more confidence because you're actually using all of the framework that you actually would be using in a real live scenario in production. Lastly, you can take the TDD approach, the test first approach, or not. It depends on how you like to build your tests. And if you wanted to, what you could do is you could lay out your tests in a test-first approach where you specify the request and you specify the response. That way you could build whatever kind of API you want after you've built your tests, and you would be taking a test-first approach. There's no problem with that. This is a good way to do this, and you will be actually guaranteeing that the API that you write is working from start to finish in a test-first approach. I'm going to use Visual Studio Code, but you can use whichever IDE you like, Writer or Visual Studio. I'm going to use the C# Dev Kit extension, which is the most common C# extension for Visual Studio. I'm just going to run a new Web API project to create the Web API. Okay, and so here we can see that we have the basic example with a weather forecast endpoint. I'm going to automate some of the steps by using the GitHub Copilot agent. Okay, so I've got it on agent mode and the model is GPT 4.1. Okay, we'll hit it with curl. On Windows, you could use something different. It's calling .NET Run to start up the endpoint. Okay, and now it's going to call curl. And this is directly hitting the endpoint. Okay, and it's saying it's using HTTP instead of HTTPS. Try again. Okay, so we got the sample response back. That's great. I've realized there's a little bit of a problem here. The files are in the root folder of the parent folder. So I'm going to move these into another one. We'll call this Web API and move everything inside this folder. Okay. Notice you can see down here projects 1. That's because there's one project in the solution. Okay, and we also have this solution here. So I'm going to click on Open Solution, even though I don't need to right now. This tells us that this is the solution that we are using. This bin folder here, we can just delete that. All right. This one here is actually the VS Code extension, and we can build our code at any point by clicking on this and clicking Build. Okay, and we'll see something come up down here. Okay, we got a tick. That's great. Right, so we have a folder here, the Web API folder, and now we're going to create a tests folder. Okay, so I go back to this project here. I'm going to create a new project, and we will create an MSTest project. You could do NUnit or any other type you like. This is just what I'm choosing right now. Okay. All right. So we also want to make this depend on the other project. So we will add that. To add that, we right click here and click Add Project Reference. That'll allow us to add the other project. Okay, that's named badly, but we won't worry about that for the moment. Okay, we have a test here, but this would just be a normal unit test. We will check here. We're not seeing the test showing up right now. Let's see what happens if we build the tests. Okay, see a tick here. Okay, and the tests have shown up, which is great. So here I can run the tests. Okay, we should get a tick because there's nothing in there. Again, I'm just going to add this, but we have a whole bunch of stuff that we don't really care about. So let's go and add a git ignore before we move any further. Okay. So we'll ignore the bin folder and the obj folder. Okay. So those ones are now ignored, and those ones are not ignored. So let's actually delete these, because we don't want to commit those into source control. Okay. Go over here. Okay, again, we're not publishing anything, we're not pushing anything. Okay, but we have our two main projects here, okay? And there is one more step we need to do. When we go into this file, we need to add a partial class, and we'll call it program. Okay, this is because we don't have a class in here. Okay, we just have top level statements that start the app. But in order to test this, we need to be able to reference this from our test project. So we have this partial class here. Now, inside the testing project, there are a few NuGet packages we need to add in order to be able to test this one. So I'm going to actually just get Copilot to try and add those, and we'll see how far it gets. Okay, we'll see what it does. At the moment, these are the packages that it references. Okay, so it's added these ones, and it has added XUnit. Okay, we don't really need that. So we're going to delete the XUnit ones. Okay. Now it's restoring the NuGet packages in this project. Okay, great. Now let's see what happens if we tell it to run an integration test on our endpoint. Okay, so the endpoint we have here is called weather forecast. Let's see if it can just figure that out. So this is much like a Postman test. It is again restoring packages. That is fine. So what it's doing here, it's creating a factory for the tests, a web application factory. And from that we get a HTTP client. That HTTP client can be used to test the endpoint. So we're calling weather forecast. I'm going to hit keep. I'm going to again delete these packages because we don't want to use that. Okay. It is now not going to compile. Okay. That's fine. I am going to remove these. I'm going to just move this into here. Delete the Xcode stuff. Okay, so here we have moved the web application factory into this, and we'll change this to r equal is not null is true. Okay, is in. Okay, I'm going to ignore this one for now. Let's run the test and see what happens. Okay, that didn't compile. Why didn't it compile? Let's see. Because the problem's here. The type or namespace, weather forecast DTO. Okay, that's right. Let's see if we can get that from the other project. No, we can't. Okay, over here it's actually just called weather forecast. All right, so I don't think we need to call it DTO. Okay, in the other one, this is not public, so let's make it public. Okay, this is a record type. It's basically a class. We can get that from here. Okay, let's see if this runs. Okay. It runs, and actually it passes. That is fantastic. Let's see if we can debug it and see what's actually happening here. So I put a breakpoint here, and I click the debug button. Okay. If I hover over this, I can actually see the forecast. And here we go. GitHub Copilot has written a valid test right off the bat without us having to manipulate any of the code. That is fantastic. It is using the DTO from the other assembly, and we can actually see the results here, which is fantastic. So the next thing I'm going to do is put an abstraction in here so we can load the data with a class. Okay, so we go back here. At the moment, we just have this as a way to return the data. Okay, but I'll move that into a class. So we'll just create it like this. I'm going to just create a dictionary for the cities, and we'll just return one by one. Okay. Okay, so we'll just set up a dictionary like this that we can just call, which is just hard-coded. Okay, so if we pass in London, we should get this weather forecast back. Okay, so this is going to require a change to the endpoint, but here we go. So it could return null, so we should fix that up, but we'll leave that for now. I like to format my code with C#A, so I will do that now. Okay. Here, okay, so this is how we do dependency injection and minimal APIs. Okay, we should do null handling here, but this is okay for now. So we're going to get different results in the data. So we have to change our test. A forecast, weather forecast. So we'll need to change this. There we go. Okay, and we can actually verify that now. Let's say R equal, and we know that London is going to be 20. Okay, so we can verify that. Let's run the test. Okay, that failed. Let's see why that failed. Okay, so perhaps the reason why this is not working, we'll move this service over here. And apply this. So something we need to do is we need to inject the service in the factory. Now, if we already have a DI container with all of our services set up, the test will use those, but we can override them. I'm just going to configure the services here. Okay, so I've just added a singleton for the data service, which is what we would really use in the real world anyway. Let's try that. And this works fine. So this is how we would actually create a mock to actually mock out the data service. This is how we can test the entire endpoint without actually hitting the database. So at the moment, we just have this implementation. I'm going to create a duplicate of that just so we can see what's going on. So I'm going to call this fake data service. So it could be a mock or a fake, whatever you like. I'm going to call this one real data service. Okay, exactly the same thing, but you can see what's going on here. Okay, and in this app, I will configure the services here. Now I'm going to add the singleton in the main project. Use real data service. I'll set the London temperature to 15 in the real data service so we can tell that we're using the fake. This is still expecting 20. Let's see if the test passes. Okay, so we're successfully using the mocked version of the data service in the test. That's because we've overridden it here. Now, if we comment this out, it's going to fail because it's going to use the real data service. So let's wrap this up and we'll just clean up a little bit of the code. Okay, so that's returning that information. We want to check that it is returning sunny and that it's returning this value. Okay. Right. Those should match. Okay, all good. That's it for this tutorial. I will put the entire repo on GitHub, and I will put the link in the comments so that you can see the actual code, the finished product. To finish off, as you can see, we wanted to use the original wire up of the dependency injection inside the program.cs. When you're building your app, you don't want to remove the composition of your app during the test. You actually want to use that. That's very valuable because that is actually part of the test. You only want to replace strategic services with mocks when that's necessary. And as I mentioned, you could actually have a flag in your test. You could have two different test cases, or turn them into a different set of tests so that you can run some with the mocks and some without the mocks. As you could see from the example, you could use a real data service. It's fine. By default, it's going to use that. And moving into future, what you would probably want to do is you would probably have a few different requests and responses, and you'd probably want to handle an error case. I will probably do another tutorial on that at another time, but at the moment, you've got enough to get started. Lastly, I like to have a baseline of endpoint tests in whatever framework I'm using, whether it's .NET or Python or TypeScript. They serve as a guarantee that the basic use cases are going to be covered for what you're doing and most of the plumbing, but it is also a good idea to have some unit tests on top. The unit tests are great, but one of the reasons why integration testing is really fantastic is that it doesn't tie your test to implementation details. Unit tests basically are implementation details when they are very fine-grained and isolated. If you have a lot of different unit tests, then the tests need to change with the refactoring. So every time you refactor, you're going to have to change the tests. And that's how unit tests can sort of bog down your system. So if you've got a very unit test heavy test suite, the system will be harder to change because they will all change every time you change your basic structure. But what you can see from an integration test is that you can keep most of the refactoring without necessarily changing the integration tests. And that's one of the biggest beauties of integration tests, is that you only need to change the tests when you refactor something like a data service or something like that that has to be mocked. So thank you, and please subscribe. Let me know in the comments if you have any questions, and contact me on one of the social media platforms. Thank you.